We are presenting case study on this topic, that is adaptive equalizer system for a visual light wireless communication utilize multi-wire LED lighting equipment by Balayokesh and Aradhike Nair. This is the introduction. A considerable number of studies has been conducted on extensive of wide modulation bandwidth. Therefore, it is important to study the visual light wireless communication system with adaptive equalizer and high speed data transmission. The similar result shows that the visual light wireless system is adaptive equalizations is robust against shadowing, can be accommodated more connection. This is the introduction, and next we see the lighting design and basic performance. We will discuss the communication performance of the typical visual light wireless environment. That small office with the general light requirement. The room is in 5 into 5 3 and the light grading is 2 into 2 with the communication function is installed on the ceiling. Each light source has 10 into 10 LEDs. This is the light design. Next we see the illuminance distribution based on light engineering. We give here the consider of illuminance light equipment. The general illuminance light is standard by the ISO, and this between 300 to 150 lux is required for office work, and the uniform ratio should be over 0.7 according to light engineers. This is the distribution based on light engineer. Next we see the average ratio optical power. The main hub is positioned at the center of the ceiling and connected to the each source. The received optical power at the receiver across the room. We can see the receiver power is very high. The consider actual situation, we seldom use terminal in a corner of the room. The right under the light equipment, the receiver power is very high. This receiver power is very high, and this is the average received optical power and propagation delay by multi-lighting equipment. In this visual light wireless system, the LED are distributed across the ceiling and have a wide range distributions for achieving general light. Since we calculate impulse response by ray tracking, the impulse response different depends on positions of receiver in visual light communication visual wireless system. On one other hand, in below few ns, one reason is that the much larger wavelength compared to visual light make radio waves reflections appear to the reflections. Therefore, the visual light wire system is much less sensitive to ISI than radio wireless system. This is the propagations, and next we see the electrical SNR. The optical channel, originally the quality of transmission is donated by short noise. The deserved signal contain a time variation short noise process which have average rate of 0.4 to 0.5 photons bit. The order of 0.7 and 0.8 photon have a noise short noise having a rate of order, that is light striking detector. Therefore, we neglect the short noise caused by the signal model of ambient induced short noise as Gaussian process. The electric resonance expresses as CNR is equal to RPR squared divided by omega short squared plus omega thermal squared. This is the expressions SNR and the electrical SNR in this slide. And next we see adaptive equalizer, and this is decision feedback equalization. The basic idea behind and the decision feedback equalization, that is DFE, is that once information symbol has been detected and decided upon, the ISI that induced on further symbol can be estimated and eliminated before deductions that subsense symbol. The FE filter is driven by decisions on the output of detector, and if coefficients can be adjusted to the cancel of ISI the current symbol for the passed detect symbol. The least means square algorithm. Since adaptive equalizer can be compensated an unknown and time variation signal channel, it's required specific algorithm to update the equalizer coefficient and track the channel various. The wider range of algorithm exists that adapted the filter coefficient, but we assume an LMS algorithm. The LMS requires as most design a minimum of square error, that is MSE, between the strain equivalent output and actual equalizer output. Here we define the input signal to the equalizer as vector yk, whereas that equation the equation series, this is mean square error. The validity of value of the step parameters and length training sequence of BER perform as a position. The relations between MSE by the LMS algorithm and the length training sequence at the receiver positions of 0.1, 2.1 and 0.85, where the FF filter has been 4 tapped and the FP filter has 2 tapped. The data drawn represented average the 100 trials. This is BER performance, and the distribution of BER performance was the receiver positions on the 0.2 M grid. We can also see that performance directly under the source is degraded, and therefore the consecution path we can sub-equal power cause error propagations. The train sequence interval we determines here the approximated training sequence interval. Here this is the stimulation. We assumed the static channel based on a calculation impulse response retracking. The horizontal axis distance between x and y, the position at the 500 m bits, there is a no error by the using appropriated weight. This is the influence of shadowing. Generally the light equipment and distributed with the room and irradiate of the light can wide angle of functions light equipment which help minimize a shadowing effect. Therefore there is a correlation between the influence of shadowing and the ISI. We consider downlink transmission based on a time division multi-axis, that is TDMA, and perform a theoretical analysis computer symbolized to the evaluated the effect of shadowing causes the predators. And we know the visual light communication system with adaptive equalizations is robust against shadowing. The conclusion is the analysis of simulation present here confirm the proposed system is various promise for the future high speed wireless access network, and it could be one of the choice for an door optic wireless data transmission system. This is the conclusion on the topic behind. Thank you guys.